Hello, good morning. It is day 10. I'm awake. I've got coffee, got a barking dog. I've been to the gym. I've been to see Santa, and I'm ready to. Josie, Josie, it's not. Yeah. Let's look at the problem and see if my dog can cool it. Avoid the roads, plunge and reverse them to shore. Hey, Josie, can it? I don't see how something like me back at the upriver, but the river's too loud to finish crossing. Priority to communication system, pull it out of your pack, out of water, slowly draining big time. Video system, CRT, clock circuit takes constant rate, cycle, start by figuring out the signal. CPU has a single register X, which starts with the value 1. It supports only 2 instructions. Add XC takes 2 cycles to complete. After 2 cycles, the X register is increased by the value V. V can be negative. No op takes 1 cycle to complete. It has no other effect. The CPU uses these instructions in a program to somehow tell the screen what to document. This final program. At the start of the first cycle, the no op instruction begins instruction. During the first cycle, X is 1. After the first cycle, the no op instruction finishes execution doing nothing. Start the second cycle, the add X3 begins execution. During the second cycle, the X is still 1. During the third cycle, X is still 1. After the third cycle, the add X instruction finishes execution, setting X to 4. At the start of the fourth cycle, the add X instruction begins execution. During the fifth cycle, after the fifth cycle, the add X finishes. He's 1 cycle to complete, has no other effect. Add X takes 2 cycles to complete. Okay, so where's this larger program? This interesting signal strength during the 20th cycle register, the signal strength. 20th cycle occurs in the middle of the second add X values register. X is the starting value plus all the other add X values up to this point. During the 60th cycle, register X has a value 19, so the signal strength is 60 times 19 equals 1140. Signal strength. Okay. Let's think about this again. No, this first cycle, X is 1 after the first cycle. During the second cycle, X is still 1. During the third cycle, X is still 1. During the third cycle, X to 4. The start of the fourth cycle, the add X 5 in execution. During the fourth cycle, fifth cycle, X is still 4. After the fifth cycle, finishes execution. Okay. So we can do that. The question is, how do I want to represent things that are yet to occur? I have 2 ideas. One is that I maintain like a priority or a queue of things that are yet to occur, or like a priority queue. Second is I just maintain a dictionary. So I will do, the dictionary is simpler, but it doesn't generalize well. But I'll do it that way, and then hopefully that doesn't clock circuit signal being sent by the CPU. What do I want to call it? Device. Data class is import data class at data class device x, which is an int and equals 1. Okay, so that's what it says. And let us say let's just say cycle int equals actually I can think of a lot of ways to do this, but actually I need cycle number. Okay, cycle int equals 1, and adapters. No, let's say these are going to be add x's. So add x's, which is going to be addict from int to int, which is going to be empty. And that's going to be bad. There's like a post init thing, right? Is that right? Data class post init. Post init processing. To generate a code comment post init if it's finding the class itself, post init, init var. What are init var? Init var is considered a pseudo field called an init only field is not returned. Init var is considered a init only field, module level fields, blah, blah, blah. Let me just do this. Def post init self, self add x's equals this. So I don't like using default values. Okay. And so let us def step instruction, which is a string, and it is going to return an int. And how am I going to do? How am I going to do this? Match instruction dot split with case no op pass, and then so I'm worried they're going to add a lot more of these, and I'm going to have designed it wrong. Now let's see what they called this thing. Add X number. Self dot add x's self dot cycle plus 2 equals int n. Okay. And then during, let me make sure. Signals, so now signal strength equals self dot x times self dot cycle. If self dot cycle and self dot add x's, self dot x plus equals self dot add x's dot pop. That way we get rid of it. And then return signal strength. So I think I understood that correctly. And okay, so let's say print cycle, self dot cycle. That's fine. So let's take this small program. and let's just say def run self instructions stir none for instructions in instructions.splitline self.step instruction. Okay, and I didn't do that. That's smart. Self.cycle plus equals 1. And now the other thing is, no, what is going on here? No. Okay, Copilot, you're getting, I don't want that. I want to tab again. Okay, good. What I want to do is I need to worry about self.exes, self.step. No, okay, good. So I basically, as long as I have things still in the queue, I want to keep doing them. So now let us try this and say, we'll see what happens. And there's going to be a second raw, so I'll do this. Device1 equals device. Device1 dot run raw 1. Okay, so let's run this and see what happens. Mutable. Seriously. This was the thing within NIDFARS that I was trying to understand. What? This is stupid. All right. So why is this? This is like super stupid. Mutable default. I get why it doesn't want me to use a mutable default, but I don't really get is not allowed use default factory. If a field specifies a default factory, field equals default factory equals dict. Is that right? See if that works. Boy, you learn something every day. Okay. Instruction no up signal strength is 1, add x 4, 3, signal strength 20. Okay, so let's see if that is right. So I see this. I think I meant daytime YouTube. The problem is that um, I never update the YouTube title, and when I name the previous day's video, it changes the live stream to that name too. So it says day 9 because not because I typed in day 9 today, but because I called yesterday's video day 9. Anyway, um, okay, so at the start, the no op instruction begins execution. During the first cycle, x is 1. After the no op, doing nothing. At the start of the second cycle, the add x instruction begins execution. The third cycle, setting x to 4. Start of the second cycle, the add x instruction begins execution. During the second cycle, x is still 1. During the third cycle, x is still 1. After the third cycle, okay, so I have a logic error, which is that this should be self.cycle plus 1, I think. So let's run this again and see what happens. During the start of the first cycle, the no-op instruction begins execution. During the first cycle, x is 1. During the second cycle, the add x3 begins execution. During the second cycle, x is still 1. X is still 4. After the fifth cycle, so final x minus 1. 1, 1, 4, minus 1. So I think that's right. Find the signal strength during the 20th. Okay. And let's say instruction string int. Self dot, let's say, so now we can make this an iterator. Okay. And let's say signal strength equals list of device.run instructions. And what do I want? I want the sum. Indexes equals 20, 60, 100, 140, 180, 220. Return return sum of signal strengths index minus 1 for index in indexes. Is that right? Because the zeroth is going to be that is right. And so let's say raw2 equals, and let's copy this nasty one. I have a lot of print statements here that I'd rather not have, but that's okay. It is not going to be that. So it's going to insist that this is going to be that. So let's run this. I doubt it'll work, but we can try it. $146. So why is it only 146? Fuck. That was my coffee. Shit. Hold on a sec. Right, well, I got coffee all over the place, so that's not good. So there's something I'm not getting here. which is as follows. These are only 146 instructions. So how, with 146 instructions, can I get let's see. During the 20th cycle, register X has a value 21, so the signal strength is 20 times 21 equals 420. 20th cycle occurs in the middle of the second. Add X 1, so the value of the register is the starting value 1 plus all the other add X values up to the point. 1, 15, minus 11, plus 6, minus 3, plus 5, minus 1, minus 8, plus 13, plus 4, which equals 21. During the 20th cycle, so why am I calling this the 10th cycle? Somehow I'm counting cycles wrong. There's something I'm not getting here. Let's see. Each instruction blocks for several cycles. Oh, is that what it says? The start. Single register source only register. Add V takes 2 cycles to complete. After 2 cycles, the X register is increased by the value V. V can be negative. No op takes 1 cycle to complete. It has no other effect. The CPU uses these instructions in a program to somehow tell the screen what to draw. Considering the following small program. At the start of the first cycle, the no op instruction begins execution. During the first cycle, X is 1. After the first cycle, the no op instruction finishes execution doing nothing. The start of the second cycle, the add X instruction begins execution. During the second cycle, X is still 1. During the third cycle, X is still 1. After the third cycle, at the start of the fourth cycle, the add X instruction begins execution. I see. So when they say that add X takes 2 cycles to run, what they mean is that it takes 2 cycles and the next one doesn't even start until after those 2 cycles. All right, I don't think they were very clear about that. Thank you. That is what I think the instructions were very clear on this point. Let me try to solve it. Okay, so um, um, So let me do a couple things and say signal, I'm just going to store them here. Okay, good. And case no op pass. Okay, so, and now I don't really need this. What I need to do is, so if there's a no op, and okay, so let's just say signal strength equals self.x times self.cycle, right? So if there's a no op, I want to do self dot signal strengths dot append signal strength, and then self dot cycle plus equals 1. Otherwise, I have an add x, and so I want to do self dot signal strengths dot append signal strength, I think twice, and then self dot cycle plus equals 2, and then self dot x plus equals int n. And then I don't need to do any of these things. So, and now let me change this. Actually, no, I don't even need to do that. I'll just say self.step instruction. So that will clean this up quite a bit. And then device equals device.run instructions. And now I can do device.signalStrengths that. So let's run that and see, let's see if that works. It's an insertion error, okay. But there's no addx's anymore, so let me I don't think I need this. Okay, so let's try this again. And now let us go look this larger program. Okay, during the 20th cycle, register X is value 21, so the signal strength is 420. Let me just print. Okay, let's try that one more time. Okay, so cycle 20, signal strength is 420. Then when I get to cycle 22, I've put Okay, so that actually seems like it's doing the right thing. So let me see if I have like an off by 1 error or something. Device equals device. Device.run raw2. SS equals device.signal strengths. Okay, so SS19, SS20. SS59 is 1140. SS 100 minus 1 is 1800. SS 140 minus 1 is 2940. SS 160 minus 1, there's no 160. Okay. SS 180 minus 1 is 2280. And SS 220 minus 1, 3942. All right. SS 219 minus 1, 218. Well, that's a real irritation that it's, I have 3942 and it wants me to have 3960. So that was during the 220th cycle. $34.72. During the 220th cycle, register X has the value 18, which it should. Oh, okay, I see. I did something really stupid, which is this should be self.cycle plus equals 1. And then I need to append self.x times self.cycle. So I need to, I was using the same signal strength even though it was incrementing 1. I'm surprised it didn't catch me earlier, but anyway. Okay, good. So what is the sum of these 6 signal strengths? So now that I've gotten that one right, it seems likely that I will have gotten this one right too. And let's just go back and say, with open day 10.text as f raw equals f.read, print run raw. So let us do that. 15220. Let's see if that's right. Okay, good. It seems like the X register controls the horizontal position of a sprite. Specifically, the sprite is 3 pixels wide. The X register sets horizontal position in the middle of that sprite. This system that knows these vertical positions, sprite's horizontal position puts its pixels. Those pixels will be drawn. Count the pixels in the series 40 wide and 6 high. The CRT screen draws the top row of pixels left to right. And the row below that, the leftmost pixel is in 0. Like the CPU, the CRT is tied closely to the clock circuit. The CRT draws a single pixel during each cycle. And each pixel of the screen as a number. Here are the cycles during which the first and last pixel each row are drawn. Cycle 1 to cycle 40. So be carefully timing the CPU instructions and the drawing operation to determine whether the sprite is visible in the instant each pixel is drawn. If the sprite is positioned so 1 to 3 pixels is the pixel currently being drawn, the screen produces a lit pixel. the screen is pixel dark. 2 pixels are drawn as follows. Sprite position, that start cycle begins executing X during cycle, CRT draws pixel in position 0, CRT row, finish executing at register X is now 16, CRT draws pixel in position 2, current CRT row, this CRT draws. Render the image. Okay, so let me see what this horizontal position of sprite, 3 pixel X horizontal middle of the sprite, and this is noticing if the sprite horizontal position. Okay, so cycle up to 240. Okay, now we need to draw. And so let's say device equals device, device dot run raw. Actually, so let me do this x's, which is a list of ints. Dot x's dot append self dot x. Okay, so now let me. So now I have this. Wait, seriously? I didn't save it. So I have all these x's, right? Should be able to determine the sprite is visible. If the sprite is positioned, one of its pixels is the current being lit pixel. Okay, so let's just say def visualize x's, which is a list of int, and it is going to return a list of ints as well. Well, how do they visualize them? They visualize them as a pound or a period. So I'll make it a list of strings. Okay. Actually, I'm going to make it a list of strings. And then in range 6 for call in range 40, index equals row times 40 plus call. Okay, row equals this, index equals x equals x's index. And now what I want is if the sprite position that one of its 3 pixels is the pixel currently being drawn, but there's gonna, again, there's an off by 1 thing, right? So CR tree draws pixel in position. No, not 0. So position 2. So we don't have an off by 1 now. So cycle 1 is position 0. This is super annoying. Um, I don't think I got this right, but we'll try it. Let's see. Visualize device.x's. I don't think this is going to work, but oh wow, it did work. That's somewhat surprising to me. Um, but R, F, Z, E, K, B, F, A. Okay, that's the right answer. Okay, good. So, yeah, anyway, the big problem here was that I didn't understand the instructions. They were a little bit ambiguous, and I guess I could have read the example better, but I didn't. So I made it harder than it was. And then for part B, I wasn't sure I understood the instructions, but I guess I did, and it seems to have worked. So that was one of those problems that was frustrating and not satisfying, and now I have to clean up a bunch of coffee. Um, Sorry for the mic being staticky. Um, anyway, that's that. Hopefully tomorrow will be a better day because I didn't enjoy that one that much. All right, cool.